One of the confusing things about working with the Hadoop ecosystem is there are a tremendous number of parts and pieces, libraries, projects, terms, new words, phrases. It's really easy to get core concepts misunderstood. And one of the concepts that I actually didn't understand the first when I was working with Hadoop is Hadoop versus HBase. So I want to take a minute to talk about it because it's really important and really central to understanding working with the Hadoop ecosystem. As I've been talking about in previous movies, the Hadoop core ecosystem consists of two parts. It consists of a new type of a file system, HDFS, and a processing framework, MapReduce. So this is a visualization so that we can really start to understand the detail around the Hadoop file system. You can see that we've got representations of files, and there are 4 files here. And as I mentioned in a previous movie, each file by default is replicated 3 times in the Hadoop ecosystem on 3 different pieces of commodity hardware. So you can think of them as cheap servers. Another implementation detail that it's time for us to think about is the size of the file system. Hadn't mentioned this previously, but the file system is designed for big data. And so unlike a traditional NTFS file system or standard file system, the size of each of these files is much larger. Traditional file systems like 8K or some small size like that. The HDFS by default is 64K or 128K and is actually tunable in config files to even larger sizes. And these are often called chunks rather than files. So it's really important when you're planning your Hadoop implementation to think about how you're going to lay out your files. And you can natively process those with the MapReduce framework. And sometimes then you can just get the result using the batch processing. However, as we'll see in subsequent movies, the MapReduce framework is written in the Java programming language as a core or some other programming languages. And some customers who are working with Hadoop really don't want to query or work with Hadoop data at that level of abstraction. And I like to say that MapReduce to Hadoop is kind of like C++ to object-oriented programming. Sometimes working with Hadoop at this level of abstraction is effective. However, at other times, you want to work at a level that is more accessible by more people in the organization. It's common that organizations have a small number of application programmers, but a larger number of analysts. So one such solution is working with a library called HBase. The way that this looks is a wide column store. So you can see on the right here, you have a table with one ID column and then a data column. And there's really no requirement for any particular values in the data column. That's why it's called wide column. You'll notice as a point of detail here that columns 1 and 2 have a name, but not 3, for example. And columns 1 and 3 have a location, but not 2. Another way to think about this is it's called schema on read. So as we'll learn later in this course, that you will need to impose some sort of schema in order to query or get the information out, but not when you put the information in. And again, you might be curious on how this table is actually created, and you do use a create table statement, which will then perform an abstraction against the Hadoop file system so that you can then work with it in a kind of a quasi-tabular format. So understand the difference between Hadoop and HBase is key and core to working with the ecosystem. A lot of people think that HBase or a query language for it, which is called Hive, is actually part of Hadoop. And although it often is in practical implementations, they are 2 separate things. So keeping Hadoop and HBase separate is an important implementation detail.